Hey everyone, Andrew Stormer here, and welcome back to my computer tutorial series where I teach you how to spec your own gaming or video editing YouTube build. Today we're talking motherboards, and there's a ton to go through, so I'm just gonna rapid fire throw a ton of stuff at you. So get ready, buckle up, strap in, set down your cup of coffee because this is gonna go fast. First thing on motherboards is socket and chipsets right here. If you are using PCPartPicker.com and you've already chosen your own CPU, you don't have to worry about these because it will automatically get rid of anything that's not compatible with the CPU, but your socket is the size of the CPU and how all the pins fit into it, and then the chipset is the compatibility of how the CPU works with the motherboard. If those don't work, CPU's not going to fit, CPU's not going to work with that motherboard. Form factor, this is the size of the motherboard roughly, and then how it fits into the case. The main ones you're going to run into are ATX and micro ATX. Micro ATX is usually like one PCI slot when ATX can have like 4. Micro is just smaller if you want to do a smaller case build when ATX is bigger, or if you want to do like an SLI build or something, that's what you'd want it for, but there are different options for that. SLI and Crossfire, if you do want to do an SLI build with your graphics cards, which if you don't know what it is, link up there to the graphics card video that I talked about SLI in. If you want to do SLI, your motherboard has to support SLI or else it's not going to work. SATA 3 gig versus 6 gig express, blah blah blah. SATA, this is just your hard drive ports, the plugs that connect your hard drives to your motherboard. Obviously, like the 6 gig is going to be faster than the 3 gig because you're transferring 2 times the amount of gigabytes. M.2, that's another type of storage device. And if you're using an M.2 hard drive, you're going to need a motherboard that has M.2 slots. RAM slots, that's how many slots you can fill with RAM. And obviously, if you have 4 sticks of RAM and your motherboard only has 2, you're only going to get 2 in there. So you got to watch out for that, and you also have to watch out for your max RAM. If you're trying to make a 64 gig build and your motherboard only supports 16 gigs, you're only going to get 16 gigs out of it. RAM type, this matters because a DDR3 RAM has different pin setup and everything than a R4. And R3 at this point is pretty much dead. The only times you'd run into it nowadays is if you're looking at an old build. If you're building something new, R3 is dead and you're going to be using 4. But you do need to make sure that your RAM and motherboard matches, or else they're not going to even fit together or work. PCI slots, these are the slots that your graphics cards, sound cards, networking cards, all that fun stuff goes into. Definitely get 16. As many times as you can, get 16. Now, there are some reasons that you wouldn't want to have 16 in all of them, but I'll go over that in another video. Basically, 16 is a lot faster than 8, and 8 is a lot faster than 4, and 4 is a heck of a lot faster than 1. Some of these, though, there is a different size to them, where your graphics cards are usually like this big of lanes when there are like sound cards with like this many lanes that fits into it, so you have to watch out for that. I just say get 16. If you're making an SLI build, then I'd try to get 16s for all your cards, but if not, whatever, that's what you're gonna have to deal with. Ethernet ports, this is just your internet cord, and if you're doing a Wi-Fi build, you don't necessarily have to watch out for this. The majority of motherboards do come with Ethernet ports. The only reason you'd really have to mess with this slider is if you want like 2 or 3 ports, but I don't know when you need that. Onboard video, this has to do with integrated graphics. Link up there to a video I just did on that. If you're throwing a graphics card in your computer, hit no. If you're doing an integrated graphics build, it depends on CPU. I don't know why you do that, and yes, dumb. Onboard USB 3 headers, this has to do with your case. So if you have a case here and you have your motherboard in here, the motherboard might have some USB 3s in the back. That's not what we're talking about. We're talking about if the motherboard has USB 3 connection compatibility with the front case USBs. If the case has USB 3 ports on the front of it, that means your motherboard needs onboard USB 3.0 headers. That means it has USB 3 compatibility through a certain cable. If you don't have the USB 3 headers on your motherboard and you have USB 3 ports on your case, they're just going to act as 2.0s. And if you have 2.0 ports on the front of your case and 3.0 headers on your motherboard, it's also going to work like a 2.0. Supports ECC, that's error correcting code. This has to do with RAM. If you have ECC Ram, then you need this in your motherboard, but I'll explain the ECC Ram when I go over RAM. Wireless networking, I always use Ethernet cables, but I'm pretty dang sure this has to do with being able to connect to the Wi-Fi through your motherboard. But if you're building a tower, I don't know why you wouldn't do Ethernet, like Cat 5 or Cat 6. Ethernet's faster, man. If we jump over here onto the Asus website, onto my motherboard, we find another spec that you need to worry about in certain cases. If your CPU has like a super high TDP, a thermal design power, motherboards have a TDP that they can support. If your CPU's TDP goes over your motherboard's TDP, your computer might not work, it might overheat, it might do something like that. And you can see that right here where it says supports CPUs up to 220 watts, which that's pretty good, except in my CPU's case because mine's like 270 or something. Rip my motherboard. If we come back to PC part picker and click on a random motherboard real quick, if you look here, it has RAID support, which I'll go over in another video, but if you do want to do a RAID build, your motherboard does have to support it. And the last thing here, really quick, memory type. These are the different speeds that your motherboard can handle. If the RAM you get is slower than any of the speeds listed on your motherboard, your RAM isn't gonna work at all with your motherboard. If you have RAM that's faster than any of these supported speeds on your motherboard, you might want to look for another motherboard to get that max speed out of your RAM, but if you don't, it'll just underclock your RAM to a slower speed that it takes. Having different options for your RAM speed, this allows for you to use a 1333 speed RAM with the same motherboard as a 2133 speed RAM. It gives you options. That's it for motherboards. I know there was a ton of information just blasted at you, but I hope you got it. If you didn't get it, go rewatch the video, or if you didn't understand anything, I have a link in the description to the other videos in this computer tutorial series. And if you're new here, I'm a gamer. I do vlogs, tutorials on computers, cameras, all that kind of stuff. So thank you all so much for watching, and I'll see you next time.